Okay, so I'm Anand. I'm working with Professor Debdeep Sarkar at the Department of Electrical Communication Engineering at the Indian Institute of Science. And our work is on FDTD, which is finite difference time domain analysis of space-time metamaterials using modulated TVTLs, which is time-varying transmission lines for frequency translation, mixing and non-reciprocity. So first I'll explain briefly what is space-time metamaterial. So these are materials whose property vary with space and time, and when I say property, it could be permittivity, permeability or the refractive index, like both. So these media properties vary with both space and time, and now what happens when they vary, like for example, if a wave is propagating through this media, what will happen to it? So we have tried to study those properties. So this is the simulation space. So this is simulation space. This is air on both sides, and this is the electric slab whose epsilon or capacitance changes. So if the epsilon changes, so we observe three phenomena: frequency translation, mixing, and non-reciprocity. So over here I have plotted. So if you change the epsilon from 1 to 2, like from one state to the other, we observe frequency translation, which is if you send a signal at F1, it will be translated to F2, which is given by this formula over here. And then if you vary the property with both, like with sinusoidally, for example, if the media property varies with the frequency F2 and you're sending it F1, then we observe the harmonics over here. So this is the second property. And the third is if you vary the media property with both space and time, then what happens is you observe non-reciprocity. So for example, if you're sending a signal, and for the forward wave, you can see the central frequency gets attenuated, while the backward traveling wave does not get attenuation. So non-reciprocity is a property where the system, the waves experience different properties when traveling in the opposite directions. So these three properties which we have studied, all the three things can be observed again if we vary the capacitance of the time-varying transmission line, which is the second part. So the first part is space-time metamaterials, where we vary the epsilon. The second part is when we vary the capacitance of a timing transmission line. So we observe the same phenomenon again. So we compared the results and we see this, like we see a correlation. So we can use time-varying transmission lines to implement space-time metamaterials. And then we did some parametric studies for like what happens if we vary the Fs and Ft, which is the modulation frequency for space and time. And we observe that if Fs is equal to Ft, we observe the maximum non-reciprocity in this case. So these are the, this is what we tried to do in this paper. Yeah, thank you.